Hey guys, welcome back to SAT Prep. This is Nathan, and let's look at a little bit of algebra. This question here reads, if y equals kx, where k is a constant, and y equals 24 when x equals 6, what is the value of y when x equals 5? So there's a lot of numbers, a lot of variables. Let's go ahead and put things into perspective. First off, you always want to write down the equation that starts the problem. So in this case, y is equal to kx. Well, that's pretty easy. Plus, it says that k here is a constant. So it's going to stay the same in all of the equations that it appears in. That's good, because what we're going to do is we're going to plug in for y and x. We already have them. It says that y is equal to 24, k will stay the same, and x is equal to 6. When we look at this problem, that's pretty easy. We know that using pre-algebra, we can divide both sides by 6 and get 4 equals k. Cool. Now, we can take the new value of k and put it back into the equation. What we're looking for is, what is the value of y when x is equal to 5? So we don't know y, but we do know k now, which is 4, and we know that x is equal to 5. So the final answer will be when you take 4 and 5 and multiply them together to get 20, which is option choice C right here. Hey guys, this is Nathan, and welcome back to SAT Prep. Today we're going to talk a little bit about correlation in graphs. This question reads, which of the following graphs best shows a strong negative association between D and T? Now, we know that X and Y are one way to represent a graph, but you can also represent it with D and T. You can see D in the X-axis down here and T as our Y. So what we're trying to do is find the associations between the two. Whenever you have a positive correlation or association, then when D, for instance, goes up, then that also means that T will go up. In the same way, if D were to go down, then that also means T would go down. Now, a negative association or correlation is the opposite. It means when one thing changes, the other one goes in the opposite direction. An example of a negative association would be if D were to go up, then T were to go down, and vice versa. So now that we understand what that means, we can look at graphs to see what happens to the points in these graphs over time. See if there's maybe a line that we can draw from it. So if we look at A over here, there aren't that many dots in a line as compared to B, C, or D. So we don't really like this answer, and we're going to eliminate it for now. If we look at B, we can kind of draw a line that looks almost like a little curve like this. It's not necessarily very clear to work with, and so there's not necessarily a strong, notice the word strong, negative association between D and T. Let's move on. We can see in C a line that looks kind of like this, and in D a line that looks kind of like this. So quite simply, if we're looking at C, for instance, you can tell that as D increases, so as the dots move towards the right, then T also increases. The dots start moving upward. In other words, D goes up as T goes up. This is a positive association, which we don't want because we're looking for a negative association. So let's eliminate that as well and move on to the end where we have D. In this case, when D increases and the dots start moving to the right, T actually decreases. With D going up and T going down, that is actually a negative association. And so we can get rid of B and select D as our final. Hey guys, welcome back. This is Nathan with SAT Prep. And today we're going to talk a little bit about a concept called parallelism. L-L-E-L-I-S-M. We're looking specifically at number 8 here, which has to do with this specific phrase. But let's go ahead and look at the entire sentence to know where we're going from. It reads, nutritionists consider Greek yogurt to be a healthy food, : it is an excellent source of calcium and protein, serves to be a digestive acid, and it contains few calories in its unsweetened, low and non-fat forms. All right, so anytime that you have a list, you want to make sure that each of the different pieces in that list are parallel to one another. Just like, if you remember from geometry, how lines can be parallel, you want your lines within a sentence or a list to match one another. You want them to have all the same pieces. So what we're looking at specifically here is the piece that this underlined portion refers to. It's the word, it's like the verb or the action that's taking place in each of these 3 parts. So if we were to look at the list, which is always something that follows a colon in this case, then we're going to take those different pieces and put them together and find out what that final third piece in number 8 needs to be, whether it should stay the same or be changed to one of these different words. You'll notice already that if you look at these 3 options, that the only things that we can change the words it contains to are going to be different versions of the verb contains. So we're looking at verb tense here. So if we're going to answer for verb tense, what we need to do is figure out what is the verb tense of the other two pieces. If we're wondering what the verb tense of the finale should be right here, then we should find out what they are here and here. So let's take a look at that. The first part's pretty easy. It says it is an excellent source of calcium and protein. Okay, so the word that we're working with is. We know that that is just a regular old present tense. Whoopsie there. And then if we look at the second part, it says, after the comma, oh, here we go, serves, right there. Let me see if I can squeeze that in this blank here. Serves. Guess what? That's also present tense. So what we should have at the ending is the present tense word of the word contains. Since we know that contains is the present tense form, then we're going to get rid of some of the other options. Containing is a present perfect or gerund form of the word because it has the letters ing at the end. In a similar way, will contain is in the future tense because it's something that will happen in the future. So we're not going to choose either of those options. We're left with contains, which is correct, and the option to leave it the same, which says it contains. So how do we know the difference between using the word it or not using the word it? Well, the answer is actually pretty simple. When you're making lists, you want to make sure that you're matching each of the different pieces. But more than that, in a list, you don't want to continue to reuse the noun, in this case, yogurt, over and over and over again, even if you're replacing it with a word like it. Because when you're making lists of things, you don't have to include that extra information. The sentence makes a lot of sense when we read it like this. Nutritionists consider Greek yogurt to be a healthy food. It is an excellent source of calcium and protein, comma, serves to be a digestive acid, comma, and contains few calories in its unsweetened, low and non-fat forms. So what we're going to end up with is just the simple word contains. Just like the two words before it, it doesn't use the word it except for the very first time that it's introduced in the first clause. So we would get rid of A, no change, and choose C, contains. Hey guys, welcome back to SAT Prep. I'm Nathan, and let's think about functions and graphs and why this number 17 isn't actually as hard as the test makers would like for us to believe. Let's look at the problem here. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? Now, something that we probably all know is that when you look at a graph, the left to right axis is known as the x-axis, and the up and down is known as the y-axis. Well, that makes sense. But did you also know that the y-axis is also known as the f of x? In other words, the function of x, what you do to x to yield the value in y. So, simply put, the left to right values are x, but up and down can also be seen as f of x. If you look at the problem here, it's asking for what value of x is the value of f of x at its minimum. Well, that's pretty easy. All we have to do is find the point in the graph where it gets the lowest, up and down. And so we can clearly see that that's right about here. So let's go ahead and find out what the value of x is when the y value, or the f of x value, is at its lowest. If we go to the graph, we can count from 0, 0, -1, -2, -3. And so the x value is -3 when f of x is at its minimum, making B, -3, our answer.